Our story begins about 4.6 billion years ago. A giant cloud of gas and dust called a nebula floated in space. A nearby supernova's shockwave disturbed this peaceful cloud. The nebula collapsed, pulled together by gravity. This led to the birth of our sun, marking a pivotal moment. With the sun blazing at the center, the remaining gas and dust swirled around it, forming a massive disk. This disk, called a protoplanetary disk, provided the raw materials for the planets, including our own Earth. Imagine a giant pizza dough, spinning and flattening out around a glowing ball of cheese. That's our protoplanetary disk. Within this swirling disk, tiny particles of dust and ice collided with each other. These collisions, driven by electrostatic forces, caused the particles to stick together, forming larger and larger clumps. This process, known as accretion, is fundamental to planet formation. As these clumps grew, their gravity increased, pulling in even more dust and gas. Over millions of years, the protoplanetary disk transformed from a chaotic jumble into a more organized system of growing planetesimals. These planetesimals would eventually become the planets we know today. In the vastness of space, gravity acted as a choreographer, guiding the movements of these growing planetesimals. They orbited the sun in a delicate dance, sometimes colliding with each other in dramatic events. Some collisions were destructive, shattering planetesimals into smaller pieces. However, some collisions were constructive. When conditions were just right, two planetesimals would merge together, forming a larger and more massive object. This process of collision and accretion continued for millions of years, gradually building up the planets. In the inner region of the solar system, closer to the sun, the intense heat vaporized most of the lighter elements like hydrogen and helium. This left behind heavier elements like iron, nickel, and silicon, which would form the rocky planets Mercury, Venus, Earth, and Mars. Imagine Earth in its infancy, a hot, molten ball of rock constantly bombarded by asteroids and comets. This was Earth about 4.5 billion years ago. The energy from these impacts, combined with the heat generated by radioactive decay within Earth's interior, kept the planet in a molten state. The early Earth was a place of intense volcanic activity. Volcanoes erupted across the surface, spewing lava, ash, and gases into the atmosphere. These eruptions released gases from Earth's interior, which would eventually form the early atmosphere. This period of intense bombardment, known as the Late Heavy Bombardment, played a crucial role in shaping Earth's future. It delivered water and other volatile compounds to our planet, essential ingredients for the emergence of life.